A Portland Community College Mathematics Telecourse. A course in Arithmetic Review. Produced at Portland Community College. When it comes to fractions, most people don't have a good feel for number size. Looking at these four fractions, most will agree that 1/8 is probably the smallest, although we're not quite sure about this. And there's just a general feel of fuzziness about all of this. This is our task of this tape, is try to reduce this to a systematic approach where you can get around that feeling of fuzziness. But first, let's look at another problem which at first glance might seem messier. Now, if you were asked about these fractions instead, they all are messier than the last four, but we'd have no problems there. We would all agree that this is the lowest, then the next one is this, then the next one is this, then the largest is this. Now, even though this is messy, why is it so much easier than the other? And the answer is, when the denominators were the same, we quit looking at them and look only at the tops, which are whole numbers, and we order them, 18, 21, 25, 36. You see, most people have no difficulty about ordering whole numbers. See, in these four, that's the lowest. Then this, right here. Then this, then that, and so on. So whole numbers are easy. Well, and you see in our last example where the denominators were the same, we simply looked at the top numbers, the numerators, which are whole numbers, and ordered them, and the fraction just went right along with it. So that's what we'll do. To order fractions, we'll build each to have a denominator equal to their lowest common multiples of their present denominators, then simply order them by their numerators. So the first task, in short, get common denominators. So back to our starting problem, asking what is the lowest number that these denominators will divide into. Well, it turns out to be the 32 itself. So 32 will become my common denominator. Now, to build each one of these to have this is simply a matter of asking how many times will this go into here. So 4 goes into 32 8 times. So I multiply top and bottom by 8. 8 goes into 32 4 times. So again, multiply top and bottom by 4. 16 goes into 32 twice. That is my fraction building number. And 32 is okay. Now, multiplying the tops out, we get these new equivalent fractions. But now, since the denominators are the same, all we have to do is order the tops alone. So 4 is the least, so this is my smallest fraction. 5 is the next smallest, so this is my second smallest fraction. This is next, so that was my third smallest fraction, and this is my fourth or largest. So, get common denominators, then order the fractions by their numerators. That's simple. In future courses, we might encounter a question like this. This could come from a science class, a machine shop, stock supply, or algebra. Is this fraction larger than this fraction? Again, we realize if these denominators were the same, we simply ask the question relative to the top numbers. So our problem now is what's the least common multiple of these two numbers? Now, they're fairly messy, so let's begin to do a little bit of review here. First, now at this stage it might be well to review just how you go about finding the lowest common multiple of messy numbers. Recall, the first thing you do is prime factor each of these numbers and write in exponent form. So doing that, we get 2 to the third power times 7 to the first power for 56, and 2 to the fourth power times 3 for 48. Then the next thing we do is list all the different bases as factors to be. So let's see, I'm going to have 4 2's, then I have a 3, then I have a 7. And we've already started here. We give to each of these bases the highest power used on any of these factorizations. So the highest power on 2 is 4, the highest power on 3 is 1, and the highest power on 7 is 1. And that number in factored form is the lowest common denominator. So we want both of them to be the same. Okay, now in factored form, the fraction building for messy numbers is fairly well simplified. We compare what we have with what we want, and then ask what additional factors do we need. So I want 4 2's, I have 3, so I'll need one more 2. Okay, I want a 3, one of them. I don't have any, so I give myself a 3. I want a 7, I've got it. So to make this look like this, I needed 6. But then I have to multiply the top by 6 as well. Now to make this look like this, I want 4 2's, I've got them. I want a 3, I've got it. So all I need to make this look like this is an additional factor of 7. So I multiply top and bottom by 7. And here I multiplied top and bottom by 6. So now multiplying the tops out, I get 54 here and 49 here. And I don't know what this denominator in factored form is just yet, but that, as it turns out, is not important. All I needed to know is that they are the same. And if they are the same, then all I need to do is look at the numerators. And now looking at the numerators, this is indeed larger than that. So the answer to the question is yes, that's true. Okay, a little bit messy, but as you get closer and closer towards higher math that you'll be using in business, social sciences, or science engineering, messy problems becomes more the order of the day. Now, of course, you'll be given the time to work it. So more and more, you should adjust yourself to doing fairly messy problems. Now, how about the task of ordering mixed numbers? Well, if all of the whole number part of the mixed numbers are different, the fractions, as it turns out, has nothing to do with it. The whole number part will do the whole job. So 38 is the smallest, 45 is the second smallest, and 60 is the largest. So in mixed numbers, when the whole numbers are all different, we can neglect looking at the fractions. But how about if the whole numbers were the same? If we have mixed numbers in which the whole numbers are all the same, then we reverse our focus. We don't look at this, we look only at the fractions. And then we ask, what is the lowest number that 15, 21, and 24 will go into? And if it's messy, we go through a proceeding like we just did to find the least common multiple. As it turns out, it's 840. It was fairly messy, and I did it on scratch paper just a moment ago. Then we ask, 15 goes in 840 how many times? And that's 56. So I multiply top and bottom by 56. Then 21 goes into 840 40 times. So I would multiply top and bottom by 40. 24 goes in 840 35 times. So I multiply top and bottom by 35. Now, these denominators are all the same, although they don't look like it here. They all happen to be 840. Now, multiplying the new tops out, we get here these three new numerators. Now, I don't want to underestimate the messiness of getting these. That took a few minutes that you don't see on the screen. It's just that one must take the time to do it. But now, this is the smallest fraction, hence this was the smallest mixed number. This is the next smallest fraction, so this is the second mixed number in order of size, and this is the third. Messy, but the thought or system behind it is fairly routine. This type of question really falls into three categories. The first category is simply this, where the size of the fractions are so extreme between them that there is no problem in ordering them, just as they are. This fraction, 7/8, is almost 1. This is considerably less than 1/2. And this is about midway between them. So we can just see that 1/3 is the smallest, 3/4 is the next, and 7/8 is the largest. Many of the simpler situations one gets into, the fractions that one needs to order are of this type, that you can simply look and your feel for the fraction is such that you can order them by that alone. So that's the first category, is just flat order them by your innate feel for sizeness of fractions. The second category, however, is such that if you haven't worked with these very much, it's not quite obvious which is the largest and which is the smallest. Although looking at these two, you're fairly sure that you think this might be the largest and this is smallest and this somewhere in between. But see, we're entering that line of fuzziness about which we talked a few moments ago. So therefore, we simply ask the question, what is the least common multiple or denominator, if you wish to think in terms of denominators, but what's the lowest number that all of these will divide into? Well, in this case, the denominators are simple enough that we can just see that it's 32 without having to prime factor. So that means we wish to build each of these fractions such that they will have that common denominator 32. So getting ready to build, we simply ask, 4 goes into 32 how many times? That's 8. So we will build it by 8, thus getting 24 30-seconds as a replacement for 3/4. And of course 23 30-seconds stays the same. See, in fact, these two are very close in size, aren't they? We can build this and we can just see by the use of a 2. And that gives me 18. And we can see that we're going to have to build this one by a multiple of 4. And this gives us 20. So now that the denominators are the same, now note, it wasn't important that I know what they were. If I didn't see them, if I had a star covering each of them up, but I knew they were all the same, that's sufficient to tell me to look just at the numerators. So we want to order from the smallest. So this is the smallest, so this is my first one. This is next smallest, so this is my next fraction in size. This is my next smallest, so this is my third largest, third smallest actually, second largest, and this is my largest. Now once you have done this, of course order them back in the original form, not in your new form, because the person you're doing it for quite frequently won't know which one of these were matched by which up here, although he or she could certainly determine it by reducing each of these. But since we're doing the work for them, let's communicate for them right from the beginning. But do you see that the key was in having the denominators to be the same? And the key to get them the same was to use the fraction building rule from the last lesson. And then the key for finding the least common multiple, if you don't see it, is that least common multiple series of lessons we had in Chapter 2 and have reviewed for the last 3 or 4 lessons. So let's do one last problem where these are quite messy, where we need to prime factor, but rather than just having me do it on the side on scratch paper, we will do this one problem in all the detail together from beginning to end. Here's a nice messy one, probably messier than anything you'll see in your lesson. So let's do this from beginning to end, showing all of our detail together and using a calculator to help with the multiplications and divisions. Our first question is to find the least common multiple of these 3 numbers. By now, we have covered and reviewed it so many times that this should be absolutely memorized. If it is not, by the way, it is very important that you stop at the end of this lesson and go back and finally nail this down. We will have a few more lessons where if this isn't smooth and comfortable and committed to memory, your lessons simply will not be possible any further. So let's go through these one by one, have them committed to memory. We're going to prime factor each number and write in exponent form. We're going to write down each different base for factors to be. Then we're going to give to each of those bases its highest exponent. So that means we forget that this exists, or this exists. Our whole focus for a few moments is on prime factoring 896 and writing it in exponent form. So we can see by looking at it that 2 goes into it, and had we wanted to, we could say, if we're allowed to use a calculator, 896 divided by 2, and that's 448. We can see that 2 still goes in even without the calculator. So that's 2, 2, 4. And please try not to use the calculator for any arithmetic that should be obvious to a person at the college level. So we can still see that 2 goes into this. 2 still goes into this. 2 still goes into this. Two still goes into this 14 times, and 2 still goes into that 7 times. So see, we have a lot of 2's in this, don't we? We have 1, 2, 3, 4, 5, 6, 7. So we can write this as 2 to the 7th times 7 to the 1st. Now this is so long and messy. As long as you're using your calculator, it's wise to go back and check it. So let's find some shortcuts. 2 times 2 is 4, times 2 is 8, times 2 is 16. Then 2 times 2 times 3 is 8, and 8 times 7 is 56. And that's 896, which is correct. So see here again, Do not use a calculator to multiply 2 times 2. You can do that mentally faster than punching keys on the calculator. The reason we say that is that there is a tendency to overuse a calculator, and surprisingly enough, on easy arithmetic, there are more mistakes made from punching accidentally wrong keys than by doing mental arithmetic. Your head, in short, is more accurate than your fingers. So when you can do it in your head, then do it. The point being here, we have prime factored 896, so we could do away with it and use this as its replacement. They are the same, just written differently. Now prime factoring 132. Again, we can see that 2 goes into this. 2 still goes into that. 2 won't, but 3 will. So in prime factored form, this is 2 2's, or 2 squared, times 1 3 and 1 11. So this may serve as a replacement to this because they are the same. Now prime factoring 270. Again, we can see that a 2 goes into 270 because it's even. But 2 won't go into this. But since 5 is so obvious and 5 is a prime number, let's use it first. There might be something lower, 3, but at least let's grab this because we see it. So 5 into 13 is twice. 5 into 35 is 7. And now we can see the 3's. But let's write them in order. I've got 1 2, 1 2 3 3's, and 1 5. And again, emphasizing the logic of what we're doing, this may replace this because they are the same. Now, once we have prime factored forms, finding the least common multiple is the easiest chore of all. We simply write down each base, different one, so there's a 2, a 3, and a 7. And this should have been a 5 to the first here, shouldn't it? And then the highest exponent used on 2 was 7. The highest exponent on 3 was 3. The highest exponent on 5 was 1. Highest exponent on 7 was 1. And we also had an 11, didn't we? Now this is an enormously large number. But the point I wanted to make, and this is why I picked such an unusual and a large number, is simply this. To find the least common multiple, or to create each of these, we don't really need to know what these are. It's simply a matter of observation. I want 7 2's, I've got them. I want 3 3's, I don't have it, so I give it to myself, reminding myself that 3 3's multiplied together is 27. I want 1 5, I don't have it, so I give myself a factor of 5. I want a 7, I've got it. I want an 11, I don't have it, so I give myself an 11. Now, multiplying these together on the calculator, if you will, 23 times 27 times, and 5 times 11 is 55. And the numerator becomes 34,155. See, we said it was going to be messy, didn't we? But now to make this look like this, we say I want 7 2's. I have 2, I need 5 more. But 2 to the 5th, if I multiply it out, is 32. I want 3 3's. I've got 1, so I need 2 more. But 3 times 3 is 9, multiplied out. I want a 5. I want a 7. I'll put it down here. I want an 11, and I've got it. So as messy as it is, the routine is simple. I'm going to have a 7 times 32 times 45, see that 9 times 5, times 7, and that gives me 70,560. And we're going to do the same thing here. I want 7 2's. I've got only 1, so I need 6 more 2's. Multiplying those out, I would get 64. I want 3 3's. I've got them. I want a 5. I've got it. I want a 7. And I want an 11. Now see, I haven't the slightest idea what this is, but I know that this and this and this are all the same because I have made them be the same through the fraction building. So now all I need to do is to multiply those. So 17 times 64 times 77 equals 83,776. Now still, without seeing what the bottom is, knowing that they're the same because I built them to be the same, I can see that this is the smallest of these three numbers, hence this is the smallest of my fractions, and this is smaller yet again, so this is my next smallest, and this is my largest, hence this fraction was my largest. So the three fractions already were in order from the smallest to the largest. Now this is inordinately messy. I doubt if you have a number that messy in your homework because you're just beginning at this stage. But in future work, this type will indeed occur with a fair frequency. So it is important that you can follow it through. But more important than that is that we will use this process of finding least common multiples not only for ordering fractions, but for much more important things than that in future lessons. So let us leave this lesson with a final strong admonition that from this point on, know this, be able to do this, knowing it's messy, knowing it takes a lot of time, knowing that you have to be careful, but do it. Until then, this is your host, Bob Fennell, wishing you good luck.